Hi, I'm Craig Johnson with IPEX electrofusion, and this is going to be a concise video on large diameter coupling installation. Large diameter couplings are considered 10-inch and above. In this case, we're using a 16-inch coupling. We're going to go through all the steps. We're going to shave this pipe, mount this coupling, and show you how to do the installation. When you receive your couplings or your fittings or anything you're going to get from us that you're going to fuse, it's going to come in a bag. Your fittings, your couplings are going to stay in that bag until time of installation. In some cases, the bag is actually part of your installation toolkit. So don't go cut them off, use them for garbage, none of that until you're done with your installation. Now we're going to take a look at our coupling. All of our couplings from 8-inch on up are going to be fabricated. You'll notice on the outside of our fabricated couplings that we have these wires. They serve two purposes. One is to ensure that this coupling remains round, so by the time you actually put it on a pipe, you still have a round coupling. And the other is to constrain it during the fusion process. Polyethylene wants to grow. These wires make sure that it doesn't grow too much. It keeps a good relationship to the wall of the pipe. When this shrinks back down afterwards and cools, these wires may have come loose from the side. After fusion, that doesn't matter. They've already served their purpose. This is an indicator tape, and it tells you that this particular coupling is IPS size because it's red. If it were blue, it would be a dip size. If it were green, it'd be metric sized. Over here, you have 3 different scannable codes. This first code, the yellow code, is a preheat code. It's not enough energy to actually do a fusion, but it warms up the coupling and gives it a good relationship to the side of the pipe before the actual fusion process. This is your fusion code. This last code is traceability. You may or may not need to use that. Depends on who you're working for on the job site. This coupling is a bifilament. You have 2 sets of inputs. That means you're actually fusing half at a time. On the inside, you're going to see our exposed wire technology. This allows for instantaneous heat transfer to the pipe. The exposed wires also minimize the effects of oxidation. You'll see this is a pretty big fusion zone. It's the biggest in the industry. On the ends and in the center, we have our cold zones. We need to inspect our pipe. We're going to start off by just removing any of the dirt on the outside with a clean, dry cloth. If it's excessively dirty, you can use water. We're going to clean the outside. We're also going to clean the inside. During the installation process, anything on the inside may migrate to the outside and get inside your fusion zone. While we're cleaning the outside, we're also feeling for any gouges, stones that are embedded in it. You want to make sure that you get all the stones out. You also want to make sure that there's no gouge that's more than 10%. If you do have a gouge more than 10%, you're going to cut that out and not use that part of the pipe. Once it's relatively clean, we're going to check for toe-in. We'll place a straight edge on it. And right here, you're going to look for any deviation away from that straight edge. This pipe is good. If it wasn't, we'd want to cut it back. You want to make sure that this wall has a good interface with the wall of the coupling to get a good fusion. We also need to check for ovality. We're going to measure on the X and Y axis and make sure that our pipe is round. This pipe's good. If we did have an ovality issue, we would want to employ a re-rounding tool to get our pipe back to round. We need to measure our insertion depth. In this case, we're going to do a spooling process where we're going to put the coupling all the way on one side and then bring it back to the correct insertion depth on the other. So for one side, we're actually going to prep the entire width of this coupling. For the other side, we're going to take half the measurement of the coupling and prep that on the other side. For this side, I'm marking the full pipe width, so I know exactly what I need to prep. I'm going to mark that at 12, 3, 6, and 9. What that does is it allows you to know if your coupling is cambered. Additionally, I'm going to make a witness mark. I use 20 inches. And I'll mark that at 20 inches and I'll draw an arrow. I'm going to do that on the other side too. When this is all assembled, I know that if it's 20 inches here and 20 inches there and I have 40 inches when I measure between, that my pipes are touching each other on the inside of that coupling. Additionally, it's important to have a nice straight cut on the end of this. This is a factory cut. This is perfect. If you don't have a factory cut and you need to cut it yourself, you need to use a pipe wrap. You need a nice straight cut. If this is cambered, you're going to end up having a spot that may be outside of your fusion zone, and you're going to get a bad fusion. So just use a pipe wrap. We've got our full coupling width marked, because this is the delivery side of our spool piece, and we've got our wavy lines. Those wavy lines are going to prove that we've removed the oxidation. That's all we're doing with scraping. We're just removing the oxidation. We're not scraping to fit the coupling to the pipe. We're just getting virgin material. If you scrape it one time and you still have some marks, scrape it again. We're going to take a moment and address updated pipe preparation procedures per ASTM F3565. You'll see where I've got my full coupling marked here. Over here is a second full coupling width, and that's divided in half. This indicated line is for our water wash area. We're going to wash with clean water the entire pipe from here all the way to the end of the pipe, making sure we don't backtrack and bring any contamination back into an already washed area. This line is our solvent wash area. The solvent we recommend is 96% or better isopropyl alcohol. You're going to take your alcohol, again thoroughly wash the pipe here all the way to the end of the pipe, making sure not to backtrack and bring any contaminants back in. Once that alcohol is completely dry, you're going to go ahead and mount your scraper. To scrape, we're going to use our 710 scraper. It's got this foot on the bottom that engages the outside wall of the pipe. The nicest large diameter scraper in the industry. We've got that set on the top. We're going to tighten up on the top. I've already set my insertion depth. My blade's already out here. Tighten our star knob there, bring it to the bottom, tighten our star knob down there, and now I'm ready to scrape. We're going to put a slight chamfer on the edge of this pipe, and that's going to allow us to put the coupling on a little bit easier. Additionally, while not required, putting a chamfer on the inside is a good idea. If there's any little bits of debris hanging there, it could cause a static charge, which is pretty bad in a natural gas system. I have already marked the final insertion depth for the coupling, so once we put this back on, we're going to push it back. We'll know where to stop. And I've done that again at 12, 3, 6, and 9. Now we need to clean it with a 96% or greater isopropyl alcohol. And we're going to clean all the way back to the full insertion depth. Make sure we don't bring any contaminants back into our fusion area. Once you're done cleaning the fusion area of your pipe, you're going to go ahead and clean the interior of your coupling. Okay, we're just about ready to mount this coupling on this pipe. Before we do that, I want to talk about the 4 factors you have in every fusion. You have heat, pressure, virgin material, and cooling without movement. We've got our virgin material. We've gotten that through our scraper. The oxidized layer is gone. The other factors we'll discuss as we come to them. Okay, we've got our coupling just started on the pipe. You'll notice that we have our bag on the coupling. I talked about it earlier. The bag is part of your installation toolkit. This bag keeps your job site away from your fusion. You've got dirt, dust, debris flying around. You want to keep the inside of this fusion area nice and clean. This also contains the heat to where you want it to be. We don't want wind flying through here. We want to make sure the heat stays as close to this fusion area as possible, and the bag helps with that as well. A lot of times on the job site, you're going to put up whatever you have on the job site to start your driving process. 4x4, piece of lumber, whatever you have laying around. When this breaks up, because it's going to break up, it keeps it outside of your fusion. We recommend using an installation disc. What this disc does for you, when you hit the center of this disc, that force goes all the way around that coupling. It protects the face of the coupling, it protects the pins on the coupling, and there's inspectors who will fail a coupling if they see any mallet marks. So this addresses all those issues. Just have somebody hold it up there for you. Go ahead, grab a hold of your sledgehammer, and have at it. We've driven our coupling all the way on, and usually you leave the bag on here throughout the process, even putting the next pipe on. You would cut a hole here, bring the other pipe up and drive it back. There's a couple things I need to point out to you, so I'm going to take the bag off for sake of clarity. Here, we've got our print line stamped into the coupling. Gives you your size, applicable codes, timestamps, manufacturing information. You'll notice that we have this coupling driven all the way on, and that's because we're going to put the other pipe face directly against this pipe face and drive the coupling back onto the receiving pipe. This here is your ancillary gap, and that's got to be uniform all the way around. It's a good way to point it out right here, but once you have the coupling pushed back and before fusion, you're going to check that ancillary gap all the way around on both sides to ensure that you get a good fusion. Now it's time to prepare the receiving side of our fusion. I've already wiped it down, checked it for towing, ovality. I've marked the insertion depth plus 1 inch. So I've got half the coupling plus an inch. And what that inch is going to do for you is when this is all put together, it's going to be proof to the inspector that you correctly prepared this pipe. So I've got my 20-inch mark, my witness mark that we talked about previously, and I've got my squiggly lines to show that I have correctly scraped the pipe. Now it's time to scrape it. Tighten it up on the top, bring it down to the bottom, tighten it up again, and we're ready to scrape. I've gone ahead and chamfered the edge of the pipe just to put a small chamfer on the edge. I'm going to go ahead and mark my insertion depth, which is half the coupling. And just like before, I'm going to mark it 12, 3, 6, and 9. Take my lint-free alcohol wipe, which is 96% or better, remember, and clean the pipe. Now we're ready to install the coupling onto the receiving end, so we're going to reposition this so we can drive the coupling onto this side of the pipe. We've got our delivery pipe with the coupling installed on it. We've got our receiving pipe here. We've got it marked out for the insertion depth. We've got our witness marks at 20 inches on both sides. You'll notice right in the center, it's nice and straight. We bothered to use a pipe wrap. If you don't use a pipe wrap, you can't get this. We know when we put this together, the faces of this pipe and this pipe are going to touch each other, and we're going to get a good fusion. We also know that all these marks are correct. If you've got an angled cut, these marks are going to be all screwed up. Now, when we bring this together, you're going to be able to see this face and this face virtually touch. You'll notice we have our coupling positioned so we've got our inputs on top and we can easily get to our barcodes. It's pretty tough when you have these on the bottom and you realize you're going to have to do everything upside down. Now we're ready to drive this on, so we're going to install our installation tool. Just like the other tool, this is going to protect the coupling and give you a bigger space to apply force. Our coupling's fully installed. We've driven it from the delivery side onto the receiving side. We know that we're where we need to be because we can see our insertion marks. And if we measure from that 20-inch witness line, 20 inches, 20 inches, we know that the ends of these two pipes are touching inside. And you can't see that in the field, but we do have a picture of it to show you right here. Now we're going to check our annular space. We're going to use a cable tie, a clean cable tie, and we're going to try to insert it between the pipe wall and the ID of the coupling. Doesn't go in very far. That's what you want. Right here we've got a spot, it goes in a little bit further. That actually doesn't go into the fusion zone, so it's okay. Here's a spot, that probably is in the fusion zone. We're going to tighten this up by preheating it. You have to preheat it anyway, and after we preheat it, we'll check it again and make sure that closed up. You preheat the coupling prior to fusion. Preheating the coupling is not a fusion. Preheating it preheats the coupling and the pipes to the same temperature, and it helps to close up any gaps that may exist. If you were to preheat this and let it cool back to ambient, you could actually take this coupling back off. It does no fusion. And the procedure for it is preheat one side, preheat the other side, fuse, go back to this side, fuse it, go back to this side and fuse it. Okay? Start with this side. We're going to put our lead ends on. This is not a resistance coupling, so it doesn't matter red or white, either side. Now it's plugged in. We're going to scan our yellow preheat barcode. Now we verify on our machine. We hit start. And we're preheating. Earlier, I told you there were 4 factors for a successful fusion. The first was virgin material, and we attained that using our scraping tool. The next was heat. We're going to attain that with our processor exciting the coils on the inside of this coupling. The next one is pressure. Now you can see we've applied some blue tape over the red. We put some blue tape on the ends. These blue areas indicate our cold zones on the inside of the coupling. These areas where the wires are, these are our fusion zones where the coils are on the inside. Now, during fusion, these coils excite, they heat up, and they fluidize the polyethylene. That polyethylene wants to migrate out and in. Now, when it migrates out or in, it's going to hit a cold zone, and that liquid polyethylene dams up. So it actually seals up the ends and it seals up the center. So as this continues to liquefy, it's trying to push out and it can't push out. And that's how we build pressure inside of an electrofusion coupling. I'm going to talk to you one more time about a pipe wrap. You'll see this black line here on the blue tape. That indicates where these 2 pipes are touching inside this coupling. They're both well into the cold zone. So we're going to get a good dam, we're going to get a good fusion. We have that because the ends of these pipes were cut nice and square using a pipe wrap. If we don't have a nice square cut, let's pretend this is the edge of this pipe. You can see, it might not enter the cold zone, or it might barely enter the cold zone. In that case, if it's not in the cold zone, this fluidized material, it's going to pour right into the pipe. You're never going to create a dam, you're never going to build pressure, and you're going to have a bad fusion. So just use a pipe wrap. We talked about the 4 factors you need for a good fusion. Virgin material, heat, pressure. The last was cooling without movement. You'll see we've installed an alignment clamp. What this is going to do through the fusion and the cooling process is keep these pipes aligned and keep them captive so they can't pull out of the coupling during the fusion process or during the cooling. We went ahead and we preheated our coupling. It closed up that gap we were concerned about. If it didn't, we can go ahead and try that a couple more times. You can preheat up to 3 times, but you do want to give about 10 minutes between each preheat cycle to give the coupling time to grow and the pipe time to expand. we've got our leads hooked up. Right now, we'd go ahead and we would scan our fusion barcode, and we would go ahead with our fusion at that point. Once you fuse it, you're going to want to mark your initials and the time, as well as the time of cooling. So everybody knows that this is the time you did it, and this is the time it's fully cooled to remove this. That way someone doesn't walk up to your work and not know what happened, if it's fused, or if something else went wrong. Okay, our fusion's complete. We need to write that on the pipe. FC, fusion complete. Your initials, or your employee number, or mechanic number, whatever you might have. The date, the time the fusion was complete. Down here, CT, cooling time. In this case, it's 45 minutes. And then this time here is when the cooling time expires. You'll notice I've got it here and here. This is a bifilament coupling. So you're going to be cooking half of it and then the other half. So in this case, we have to write it 2 times. This is a smaller coupling that was a monofilament. You'd only be writing it 1 time because there's only 1 fusion. If you should encounter a pipe whose OD is suspect, you're going to want to verify that it's within tolerance for fusion. The minimum and maximum ODs can be found in our catalog. And to verify these, you're going to employ a pie tape to measure that. In this case, we have a pie tape on a 16-inch pipe. These increments up here are 25 thousandths per. Down here, we're going to see we have 16, and the 0 is slightly below the 16, indicating this is smaller than 16-inch pipe. So it's a 15. You can see here, these are tenths, 0.9. Up here, we are the 0.75 mark, and then we would add the corresponding digits from up here. So in this case, these lines begin to line up just about to 20. So we have a 15.9, and take the 0.75 plus 20, 15.995 inch pipe.